सिर्फ 45 डेज बचे हुए हैं नीट के लिए। तो चलो जी जान डाल के जो इतना हो सकता है मेहनत करते, बाकी ऊपर वाला के हाथ में। मेरा मेहनत 100% मैं दे दूंगा, जो होगा देखा जाएगा। चलो मेहनत करते हैं अच्छे से। चलो फिर यार इस जो होगा तो होगा यार, और अच्छे से करना था यार, क्या होगा यार। ठीक है जो हो जाएगा, चलो पढ़ाई करते हैं। The codon is triplet. The codon is triplet. 61 codons code for amino acid and 3 codons do not code for any amino acid. The codon is triplet. The codon is triplet. The codon is triplet. 61 codons code for amino acid and 3 codons do not code for any amino acid. Hence they function as stop. Hence they function as stop. Hence they function as do not code for any amino acid, hence they function as stop codons. Some amino acids are coded by more than one codon. Some amino acid are code. Some amino acid are code for. Some amino acids are coded by more than one codon. Some amino acids are coded by more than one codon. Some amino acids are coded by more than one codon. Hence the code is degenerate. Hence the code is degenerate. The codon, hence the code is degenerate. The codon is read in mRNA. The codon is read in mRNA messenger RNA in a contiguous fashion. There are no punctuation. 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 The code is nearly universal. The code is nearly universal. The code is nearly universal. For example, the code is nearly universal. For example, from bacteria to human. For example, from bacteria to human. Uracil would code for phenylalanine. Some exception to this rule have been found in mitochondrial codons. Have been found in mitochondrial codons and in some protogens. AUG has dual function. It codes for methionine. Its code AUG has dual function. It codes for methionine. AUG has dual function. अरे भाई AUG has dual function. It codes for methionine. And it also acts as initiator codon. UAA and UAG. UGA are stop terminator codon. UAG, uracil, adenine, guanine, adenine are stop terminator. Stop terminator codon. If following is the sequence of nucleotides in mRNA, predict the sequence of amino acid coded by it. Predict the sequence of amino acid coded by it. UAA, UAG, UGA are stop codon. UGA are stop terminator codon. If following is the sequence of nucleotides in mRNA, predict the sequence of amino acid coded by it. Take help of the checkerboard. AUUG, UUC, uracil, cytosine, cytosine. Now try the opposite. Following is the sequence. Of amino acid. Coded by mRNA. Following is the sequence of amino acids coded by an mRNA, predict the nucleotide sequence in the RNA, methyl, phenyl. Do you face any difficulty in predicting the opposite? Can you now correlate which two properties genetic code you have learned? Mutation and genetic code. Mutation and genetic code. The relationship between genes and DNA. The relationship between genes and DNA are best understood by mutation. Are best understood. DNA are DNA. The relationship between genes and DNA. The relationship between the relationship between genes and mRNA. Genes and DNA. The relationship between genes and DNA are best understood by mutation studies. You have studied about mutation and its effect in chapter 5. Effect of large deletions and rearrangement in a segment of DNA are easy to comprehend. It may result in loss or gain or gene and so function. The effect of point mutation will be explained here. The effect of point mutation will be explained here. A classical example of point mutation is the change of single base pair in the gene, or for beta globin chain that result in the change of amino acid residue glutamate to valine. It result into a diseased condition called as sickle cell anemia. Effect of point mutations that inserts or deletes a base in a structural gene can be better understood by following simple example. Consider a statement that is made up of the following words, each having three letters like genetic code. Ram has red cap. Consider a statement that is made up of the following word having three letters like genetic code. Okay, Ram has red cap. Yes, if we insert a letter B in between has and red, rearrange the statement. Bread Ram has bead cup. Similarly, if we now insert two letters at the same place, say bi, Ram has b read shape. Okay, say by. Now it would be read. Now we insert three letters together, say big. Okay, the statement would read Ram has big red cap. Okay, the same exercise can be repeated by deleting letters red by one and readding the statement to make a triplet. Okay, Ram has edc cap. Okay, red জায়গায় বি তুই একটা যোগ করতে পারিস here Ram has a blue, not blue, red তো হলো red blue white. Ram has a hot cap হতে পারে. The conclusion এইটা HED cap HEDCA আলাদা করে পড়ে থাকবে DCA. Okay, Ram has sheet cap. Okay, so the conclusion from the above exercise is very obvious. Insertion or deletion of one or two base change the reading frame from the point of insertion or deletion. However, such mutation are referred to as frame shift insertion, frame shift insertion or deletion mutation. Frame shift insertion or deletion mutation. Insertion or deletion of three insertion frame deletion mutation বা frame shift deletion mutations are frame shift insertion or deletion of three or its multiple base insert or delete in on or multiple codon, hence on or multiple amino acid, and reading frame remains unaltered from the pointers. Frame sheet insertion or deletion mutation referred to as frame sheet insertion, frame sheet insertion, frame sheet insertion, frame sheet insertion, frame sheet shift insertion or deletion mutation, insertion or deletion of three or its multiple bases, insert or delete it all or multiple codon, hence on or multiple amino acid, or delete in on or multiple codon, hence on or multiple amino acid, and reading frame remains unaltered from that point onward. tRNA, the adapter molecule. tRNA, the adapter molecule, from the very beginning of the proposition of code, of the proposition of code, the from the very beginning of the proposition of code, it was clear to Francis Crick that there has to be a mechanism to read the code and also to link it to the amino acid, because amino acid have no structural amino acid have no structural specialty amino acid because amino acid have no structural specialty because amino acid have no structural amino acid because amino acid have amino acid have no structural specialties to the amino acid because amino acid have no structural specialty to read the code uniquely. He postulated the presence of an adapter molecule. That would on hand read the code and on other hand would bind to specific amino acids. The tRNA, then called sRNA, soluble RNA, was known before the genetic code was postulated. However, its role as an adapter molecule was assigned much later. The tRNA, then called sRNA, soluble RNA, was known before the genetic code was postulated. However, its role as an adapter molecule was assigned much later. The tRNA, then called sRNA, the tRNA, due to the presence of an adapter molecule that would on the code and on other hand would bind to specific amino acid. The tRNA, then called soluble RNA, was known before the genetic code was postulated. However, its role as an adapter molecule was assigned much later. However, its role as an adapter molecule was assigned much later. However, its role as an adapter molecule. However, its role as an adapter molecule was assigned much later. tRNA has an anticodon loop. tRNA has an anticodon loop. tRNA has an anticodon loop. tRNA has an anticodon loop that has bases complementary to the code, and it also has an amino acid acceptor end it would be has an amino acid acceptor end to which it binds to amino acid. tRNA are specific amino acid acceptor end which is bind to amino acid. tRNA are specific for each amino acid. tRNA are specific. tRNA are specific for amino acid. tRNA for a specific amino acid. tRNA for a specific amino acid. tRNA are specific for each amino acid. Each amino acid for initiation there is another specific tRNA. There is another specific tRNA that is referred to as which it binds to amino acid. tRNA are specific for each amino acid. tRNAs are specific for each amino acid. For initiation, there is another specific tRNA for initiation. There is for initiation there is another specific tRNA that is referred to as initiator tRNA. There are no tRNA for stop codon. There are no tRNAs for stop codon. The secondary there are no tRNAs for stop codons. The secondary structure of tRNA has been depicted that looks like a clover leaf. If in actual structure, the tRNA is compact molecule which looks like inverted L. The tRNA is a compact molecule. tRNA is a compact. tRNA is a compact molecule. 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 पढ़ाई करिए चलो ओके tRNA initiator tRNA there are no tRNAs for there are no tRNAs for stop codon. tRNA is a compact molecule which look like inverted L, which look like inverted L. Translation refer to the process. Translation refer to the process of polymerization. Translation refers to the Translation refer to the process of polymerization. Translation refers to the process of polymerization. Translation refers to the process of polymerization of amino acid to form a polypeptide. Translation refers to the process of polymerization. Translation refer to the process of polymerization of amino acid to form the water and sequence of amino acid are defined by the sequence of bases of the water and sequence the water. यार पढ़ाई करो China is a compact inverted which look like inverted say okay. Translation refers to the process of polymerization of amino acid to form a polypeptide. The order and sequence of amino acid are defined by the sequence of bases in the mRNA. The amino acid are joined by bond. The amino acid are joined by Allah help me. Allah help me, please. Allah help me. তো কিছুই দেখতে পাবো না। ওকে, টিআরএনএ পলিপেপটাইড, টিআরএনএ ফরমেশন অফ অ্যান peptide bond requires energy. Okay, the order and sequence of amino acid, the order and sequence of amino acid, the order butter chicken क्या है रे भाई? The order and sequence of amino acid are defined by the sequence of bases in the mRNA. Sequence of bases in the mRNA. The amino acid are joined by a bond. The amino acid is known as peptide bond. Amino acid joined by a bond. Amino acid क्या है? Amino acid হচ্ছে কি joined by a bond which called peptide bond. Amino acid that bind by a bond, joined by a bond, which known as peptide bond. Formation of peptide bond requires formation of peptide bond. Formation of peptide bond. Formation of peptide bond requires energy. Formation of peptide bonds requires energy. Therefore, in the first phase itself, in the first phase itself, therefore, in the first phase itself, amino acids are activated in the presence of ATP and linked to their cognate tRNA. Link their cognate tRNA, a process commonly called as charging of tRNA or amino acylation of tRNA, called charging of tRNA, or amino acylation of tRNA, amino acylation of tRNA, amino acylation. उफ, चल कर लूंगा रे. Doctors can't give up until their last breath. Doctor can't give up. Doctor can't give up. जान देना है, जान देने के लिए भी तैयार है. तब तो डॉक्टर माना जाएगा ना. एक डॉक्टर एक डिवोशन है. डॉक्टर एक इज्जत जैसे एक डिवोशन है. डॉक्टर बनना कोई आसान काम नहीं है भाई. ओके, ओके, 10 बजे चल जाएंगे यार. The if two such charged tRNAs are brought close enough, the formation of peptide bond between them would be favored energetically. The presence of catalyst. The presence of a catalyst would enhance the rate of peptide bond formation. The cellular factor is responsible for the cellular factor is responsible for synthesizing protein. Synthesizing protein is the ribosome. The cellular factor responsible for synthesizing protein is the ribosome. The ribosome consists of structural RNA and about 80 different proteins in its inactive state. The ribosome consists of structural RNAs and about 80 different proteins. The ribosome consists of structural RNAs. The ribosome consists of structure. The ribosome consists of a structure. The ribosome consists of a structural RNA and about 80 different proteins. It exists as two subunits, a large subunit and a small subunit. कुछ बन जाओ यार, वरना तुम्हारा जिंदगी में कोई वैल्यू नहीं है, कोई तुम्हें इज्जत नहीं देगा. The ribosome consists of structural RNA about 80 different proteins in minutes inactive state. पापा सो गया। क्या गलती कर दिया मैंने रे, बहुत बड़ा गलती। कितना वादा था मेरा पूरा मेरा ऊपर आग डाल के बैठा। सबकी इज्जत मिट्टी में मिला दूंगा। अच्छा मैं कैसे बंदा हूँ रे। Give me strength, give me more knowledge. Please help me, bro. For subsequent amino acid. Hello. Okay, bhai. There we go. There are two sites in the large subunit for subsequent amino acid to bind to and thus be close enough to each other for the formation of peptide bond. The ribosome also acts as catalyst. The ribosome also acts as catalyst 23S RNA in bacteria is the enzyme ribozyme 23S. RNA in bacteria is the enzyme ribozyme. For the formation of peptide bond, a translational unit in mRNA is the sequence of RNA. A translation unit in mRNA is the sequence of RNA that is flanked by the start codon AG, and the stop codon and codes for polypeptide. And mRNA also has some additional sequences that are not translated and are referred as untranslated regions (UTR). The UTRs are present at both 5' end before start codon and 3' end after start codon. They are required for efficient translation process. They are required for efficient translation process. They are required for efficient translation process. For initiation, the ribosome binds. The ribosome bind to the mRNA at the start codon AUG, that is recognized only by the initiator tRNA. The ribosome proceeds to the ribosome proceeds to the elongation phase of protein synthesis. During this stage, for initiation, the ribosome binds to the mRNA at the start codon AUG, that is recognized only by the initiator tRNA. The ribosome proceeds to the elongation phase of protein synthesis. During this stage, complexes composed of an amino acid linked to RNA sequentially bind to the appropriate codon in mRNA by forming complementary base pair with tRNA and codon. The ribosome moves from codon to codon along the mRNA. Amino acids are added one by one. Translated into polypeptide sequence dictated by DNA and represented by mRNA. At the end, a release factor binds to the stop codon. Release factor terminating terminating translation terminating translation and releasing the complete polypeptide from the ribosome. Regulation of gene expression. बोलो এই যে মন্টু শিখছে রে। হ্যাঁ, আচ্ছা। হ্যাঁ, আচ্ছা। Focus. The regulation of gene expression referred to a very broad term that may occur at various levels, considering that gene expression result in the formation or it can be regulated at several levels. In the regulation could be stated at transcription, processing level, transfer RNA from nucleus to the cytoplasm, translational level. The genes in a cell the gene in a cell are expressed to perform a particular function or a set of functions. For example, if an enzyme called beta-galactosidase is synthesized by E. coli, it is used to catalyze the hydrolysis of a disaccharides, lactose into galactose and glucose. Like the bacteria use them as a source of energy. Hence, if the bacteria do not have lactose around them to be utilized for energy source, they would no longer require the synthesis of the enzyme beta-hydroxylase. Therefore, in simple terms, it is the metabolic, physiological, or environmental condition that regulate regulate the expression of genes, the development and differentiation of embryos into adult organisms are also a result of coordinated regulation of expression of several sets of genes. In prokaryotes, control of the rate of transcription and initiation. Initiation is the predominant site for control of gene expression. In a transcription unit, introduces the activity of RNA polymerase as the given promoter is in turn regulated by interaction with accessory proteins, which affect its ability to recognize start site. These regulatory proteins can act both positively. These regulatory proteins can act both positively activators and negatively repressors. The accessibility of promoter, the accessibility of promoter regions, of prokaryote DNA is in many cases regulated by the interaction of proteins with sequence termed operators. The operator region is adjacent. The operator region the operator the operator region is adjacent to the promoter element. In most operands and in most cases the sequence of the operator bind a repressor protein. Each operon has its specific operator and specific repressor. For example, lac operator is present only in lac operon and it interacts specifically with lac repressor only. The lac operon. The lac operon. यार पढ़ाई करो. पढ़ाई एक शेरनी का दूध है जिसने ये पिया वो दौड़ा है. आप जम के मेहनत करो. ऐसे मेहनत करो कि आज तक किसी ने सोचा भी नहीं होगा कि ऐसे मेहनत भी हो सकता है. फाड़ दो, उखाड़ के रख दो आपके सारे के सारे सब्जेक्ट्स को. जहाँ से भी क्वेश्चन आया एकदम सटक से आंसर देना, तब ना आ जाएगा मजा. क्या कर रहे हैं? The lac operon. The elucidation of the lac operon. The elucidation of the lac operon was also result. The elucidation of the lac operon. The elucidation of the lac operon was also a result of a close association between geneticist. The elucidation of the lac operon was also a result of close association between geneticists. Francis Jacob and biochemist Jacob Monod. They were the first to elucidate. They were the first to elucidate a transcriptionally regulated system. Transcriptionally regulated system in lacoperon. Here lac refers to lactose. Lac for lactose, a polycystronic structural gene. A polycystronic structural gene is regulated by common promoter and regulatory genes. Such element is very common in bacteria. हाँ কারেন্ট চলে গেলে লাইটটা জ্বলে. हाँ ওটা দুবার আমি বন্ধ করেছি, বন্ধ হয় না. আচ্ছা ফের আর বন্ধ করতে হবে. হ্যাঁ আচ্ছা ঠিক আছে, আমি শুয়ে পড়ছি. আচ্ছা. Where lac refers to lactose. Here lac refers to lactose. जो भी देख रहे हो भाई पढ़ाई करो. ओ मौसम खराब चल रहा है मेरा भी और वेदर का भी. Lac refers to lactose, a polycystonic structural gene is regulated by a common promoter and regulatory genes. Common promoter common promoter and regulatory genes. Such arrangement is very common in bacteria and is referred to as operon. To name few such example, lac operon. To name few such examples, lac operon, TRP operon, and ARA operon, Hayes operon, Val operon, etc. नहीं मत कर मत कर, तेरे लिए कोई है वो स्कैटरिंग चल रहा है बाहर। आसमाने में खोला छत पे बैठा हूँ, वहाँ पे विद्युत चमक रहा है। अब थोड़ी देर में साउंड भी सुन सकते हो। TRP operon, the operon, operon, Val operon, etc. चला जाना चाहिए। मौसम खराब है या चले जाना होगा। रुक जाओ, चला जाऊंगा और 6 मिनट पर। खत्म कर दूंगा। YZY, अरे ये Z1। Galactose and glucose. Galactose, glucose. The Y gene codes for permease. The Y gene code for permease. The Y gene code for permease, which increases permeability of the cell to beta galactosides. The A gene encodes a transacetylase. Hence, all the three genes products in lacoperon are required for metabolism of lactose. In most other operons as well, the gene present in the operon are needed together to function in the same or related metabolic pathway. सुन सकते हो बाहर कितना गर्जन हो रहा कि बहुत दर्द हो रहा है स्पाइनल कॉर्ड में पढ़ाई करो वरना क्या होगा देर ट्रांसक्रिप्शन इंड्यूसिंग यूनिट दे दे, क्या होगा? आने दे, कौन आ रहा है? बढ़िया है। Maintenance project, DNA, fingerprint. ओफ, जो भी एक बंदा देख रहा है भाई, आई विश कि तुम सफल हो जाओ। ओफ, एक भी स्टार्स नहीं दिखाई दे रहा है, पूरा स्काई क्लाउड में भर गया, क्लाउडी स्काई है, कहीं डांस हो रहा है, एक एरोप्लेन जा रहा है, दिखाओ, ये देखो, नहीं दिखा, माहौल है ऐसे, नहीं देखो, कहाँ पे हो अभी देख लो, अच्छा कहीं है, देख रहे हो ना? थैंक यू यार। और असली रहने दो भाई।